Hello friends, welcome to Power Electronics. Today we will discuss the full wave converters. There are large varieties of SCR controlled converters. We can also name them as rectifiers. As we know, a rectifier is a device that converts AC to DC. So there are large variety of them. As per the classification, the AC to DC converters we have already discussed in the previous class of R load with RL load, freewheeling diode. This we have discussed. These all were the single phase half wave converters. Three phase control converters, as we know, the name suggests that it has three phase supply, or we have the single phase, that means it have a single phase supply. If you look at the classification, in single phase half wave controlled rectifier, first of all, students should not confuse in between them. This is single phase half wave controlled rectifier or single phase one pulse converter. These both things are same. Single phase half wave controlled rectifier and single phase one pulse converter. And if you classify it with another, we find that single phase full wave or single phase two pulse converter. Here it is two pulse converter. So what is the meaning of half wave or one pulse? It is the one pulse of the load current during one cycle of the source voltage. So if you look at this, if this is the source voltage here, Vs is the source voltage, so the load current conducts only for the half of the cycle. So it conducts for half of the cycle. Its meaning is that one pulse of the load current during the one cycle, this for complete cycle. Here this is the complete cycle, it starts from 0 and at here for one complete cycle of the source voltage it has one pulse of the load current. So we should remember that single phase half wave control rectifier, single phase full wave control rectifier. So here the single phase half wave control rectifier has, so disadvantages are fulfilled by single phase full wave or single phase two pulse converter. If you look at the diagram, this is the single phase two pulse midpoint converter. If you look at this diagram here, as you can see here, it is the single phase two pulse midpoint converter. Single phase midpoint converter. So this is the transformer side that is provided by the single phase supply with the voltage Vs. Here it has a midpoint, load is connected in between the midpoints. The upper is the thyristor T1 and lower part is thyristor T2. So it is called as single phase because supply is single phase two pulse midpoint converter. Also you can see the three pulse converter here. So second way of doing the configuration is that by using the bridge converters. So how do it look like? A single phase full wave or two converter. It has 4 SCRs. If you look at here, it has 4 SCR. 1, 2, 3 and this is 4th. This is provided by the single phase supply. So single phase supply with the 4 thyristors. The second configuration uses SCR in the form of bridge circuit. Single phase full wave or two pulse, or we called as single phase or two pulse. Two pulse bridge converter using 4 SCRs. And three phase, this is three phase and three phase bridge converter using 6 SCRs. A bridge converter has some kind of advantages over midpoint converter that we will discuss in the detail. If you look at the here advantages, in a single phase two pulse or full wave converter. Voltage at the output terminal can be controlled by adjusting the firing angle. So we can adjust it by controlling the firing angle. After how much delay we trigger the SCR. Midpoint or bridge type circuits may be used for AC to DC conversions. In the first section, the first midpoint and then bridge type will be discussed in very detail. Thank you very much.